Mention here another little detail about going back to GCF, factoring a little bit. Say I had this problem, and let's note here that there's a GCF, 3x parentheses x plus 7 plus 4y parentheses x plus 7. Yeah, there is a GCF there, meaning a factor that's common to both parts. I've got two parts here, this part and then this part. A little different than previously we encountered with common factors, but there is a common factor. What is the common factor here between those two expressions, terms? The x plus 7, okay? Yeah, there's an x plus 7 that's common amongst those two parts there. Well, what do I do if I have a common factor? Well, I pull it out, so to speak, pull it out front. So yeah, the GCF here just so happens is x plus 7. So yeah, just like if I had 6x squared plus 9x, there's the GCF of 3x. On that, I pull that GCF out front. All right, that's what I'm going to do here. So I'm going to pull that GCF off of both of those out front here. Put it in parentheses because it's grouped together. Now, what goes on the other side there? Well, essentially, again, what I'm doing is I'm dividing off the x plus 7, or taking the x plus 7 out of that. So if I take the x plus 7 out of that, leaves me 3x. X plus 7 off that, leaves me 4y. All right. So there you go. A little different format, but it's also going to play a role here in just a second. So what would I get on this one? 6x squared parentheses x minus 5 minus 11 parentheses x minus 5. What would I get if I factored on that one? Well, the common there is x minus 5. Okay, so I'm going to factor it out, and that's going to leave me what? 6x squared minus 11. Okay. All right, we're going to, like I said, utilize that here for this next. What I want to talk about next is factoring polynomials that have 4 terms. Factoring 4-term polynomials. For example, x squared minus 2x, x cubed, excuse me, minus 2x squared plus 4x minus 8. X cubed minus 2x squared plus 4x minus 8. All right, well, turns out when you have 4 terms, one way you can look at factoring, won't necessarily always work, but a lot of times for us it will, is we'll look at what's known as factor by grouping. What that means is I'm going to group these. There's 4 terms, so they group nicely into pairs, 2 and 2. Yeah, I'm going to group the first 2 together, and I'm going to group then the last 2 together. All right. So if I do that, then just look at the first 2, and just on the first 2, I mean, there's no GCF amongst all four, right? There's no common factor of all four. If there was, I'd pull that out, but there's not. However, if I group them 2 by 2, notice there is a GCF amongst the first two if I just look at them separately. What GCF do those have? X squared, okay. So I've got an x squared common to both those. So I'm going to take off, just off of those two, take off the x squared. So what does that leave me? If I bring out the x squared, what does that leave me? Well, for x cubed, that leaves me x. And then minus 2x squared. Taking out the x squared leaves me a minus 2. All right. So that's my first group. Now what about my second group? Well, similar thing there, yeah. Those two separately have a GCF of 4, and you do need a sign, and it's positive 4 here. That I'm going to take out. So if I take off the 4 of those two, what does that leave me? X minus 2 in the parentheses. Aha! So by grouping those and then taking off the GCF amongst just the separate pairs there, notice what I have now. Well, I have this and this, but by our previous discussion, what do I have here that I can do? I have a common factor, don't I? I have an x minus 2 common factor, so I can take now off of those, factor out the x minus 2. Well, I'll take it off of that, it leaves me x squared. Take it off that, it leaves me plus 4. Voila. We have factored this polynomial, haven't we? Because we've taken a polynomial, now we've written it as 2 polynomials multiplied together. Factor by grouping. Okay? All right, let me give you a couple more examples. If everybody's got that one. I'm okay? All right, what about this one? 2p squared plus 6pq plus 3p plus 9q. 2p squared plus 6pq plus 3p plus 9q. So again, this strategy is good for the 4 terms. I've got 4 terms there. So let's group them 2 and 2. Off the first 2, what do you see? What have I got in common amongst the first 2? 2 and p, okay. 2p, common with the first 2. So if I take 2p off of those 2, well, that leaves me p. 2p off the 6pq, 3q, plus 3q. Hopefully a similar thing happens over there for the last 2. Yeah, the last 2 have something in common, don't they? 3, positive 3. And so if I take off a positive 3 there, that leaves me p and 3q. Does it not? And so yeah, this works out because these 2 things exact matches. They're not exact match. We may have to work on a little bit, but they are an exact match, so that's a common factor. So I can factor out a common factor of p plus 3q, and what does that leave me? 2p plus 3. So there you go. All right? Let's try this one. 27 y to the 4th minus 18y cubed minus 12y plus 8. 27y to the 4th minus 18y cubed minus 12y plus 8. All right, well, same story. We've got 2 here, 2 here. So I do want at the GCF, there's a 3 in common, but 9 would be better. And then y to the 3rd. For the first 2, 9y to the 3rd, common factor. You with me on that? All right, what does that leave me here? Take it off there, 9y cubed, so it'll be 3y. 9y cubed off of that, minus 2. Okay? Common factor of the last two is 4. So let's say we do positive 4. That leaves me a minus 3y plus 2. Which brings up the reason I bring this one up. Because for this to work, these two things have to be an exact match. If that's 3y minus 2 and that's 2y plus 3, this isn't going to work out very well. Or, as we have it now, not so good, because are these exact matches? Not quite. Because you've got 3y minus 2 and you got minus 3y plus 2. However, we can fix this one. Because what can I do here instead of 4, make it a minus 4? Yeah. I can sometimes have to take off this last part here. And usually, a lot of times, if this is a minus, that third term's a minus, then that's a pretty strong hint that that one needs to be a minus. But yeah, if I do a minus 4 instead off of these two, minus 4, well, dividing that by minus 4 leaves me a positive 3y. And dividing out a minus 4 on that leaves me a minus 2. So taking out a minus 4 fixes our little problem here. Because now we have both the binomials are 3y minus 2, so I can factor it off. 3y minus 2, so that leaves me 9y cubed minus 4. How about that? Question or concern?